What if an AI could do more than just follow commands? What if it could actually explain itself, reveal its own secrets, its own potential? Today, we're diving deep into Prometheus, an AI system that promises to do just that. So get ready, because the black box of artificial intelligence is about to be cracked wide open. And look, that's not just some sci-fi question. It's the whole idea behind Prometheus. Throughout this explainer, we're going to use the system's own self-analysis to understand how it works, what makes it tick, and where it's headed. The AI itself is going to be our guide.
So here's our game plan. We'll start with what Prometheus is, then get into how its intelligent agents work. We'll look at the core theories it's built on, its leap into quantum computing, the real-world impact from Brazil to the globe, and finally, the big ethical questions it raises. Let's get started.
All right, first things first. What really, at its core, makes Prometheus different from all the other AIs out there? Here's the first big paradigm shift. Prometheus isn't one single AI brain. Forget that monolithic model. You gotta think of it more like a digital beehive, an ecosystem of smaller, autonomous AIs. They're called agents. The real value here? Radical scalability. If a logistics problem gets 10 times more complex, you don't need a 10 times bigger AI. You just add more specialized agents. The system grows right along with the challenge.
Okay, so multi-agent, that's the big idea. But how does this digital beehive actually operate? Let's peel back the layers and look at the mechanics behind the collaboration.
This is the key. There's no central boss calling the shots. We're talking about a network of autonomous digital specialists. Imagine one agent that's focused on energy consumption, another on data traffic, and a third on security. They don't just cooperate, they actually negotiate with each other in real time. Hey, I need more processing power for 5 seconds. Can I borrow some? It's that kind of dynamic teamwork that lets them optimize incredibly complex systems, from power grids to supply chains.
And this collaboration isn't static. It happens through this constant cycle of self-organization. First, the agents sense their environment. They're gathering data. Next, they coordinate and negotiate who does what. And, most importantly, they learn from every single outcome, good or bad. Each cycle makes the whole beehive smarter. It's a system that doesn't just work, it evolves. Now, an architecture this ambitious doesn't just pop out of nowhere. It's built on the shoulders of giants, decades of theoretical research. Let's look at the two main pillars holding Prometheus up. The first pillar is game theory. Basically, it allows each agent to figure out its best move by predicting how all the other agents are going to react. Think about network security. A simulated invader agent tries to find a weakness. The defender agents use game theory to predict its moves and shift defensive resources in the most optimal way, before an attack even happens. It's all about being proactive, not reactive. And the second pillar is reinforcement learning. This is where the system truly gets smarter. So how does it work? Well, if a team of agents figures out a way to optimize a logistics route and saves 10% on fuel, the system gets a reward signal. That positive feedback reinforces the successful strategies, making them more likely to be used again. It's a constant loop of trial, error, and optimization on a massive scale. And the theoretical foundation goes even deeper. Concepts like decentralized coordination are absolutely crucial. It means there's no single point of failure. If one agent goes down, the system just reorganizes and keeps on running. And these trust and reputation mechanisms, they basically work like a credit score between agents, making sure that collaboration is always based on a history of reliability. All these pillars together create an architecture that is, by its very design, incredibly resilient.
So we've seen the architecture and the theory behind Prometheus as it is today, but its own documentation points to a next frontier that could completely redefine its limits: the quantum leap.
To get the difference, think of it like this. Classical computing processes information step by step, like reading a book one page at a time. Quantum computing, on the other hand, can explore millions of possibilities all at once. It's like reading every book in a library simultaneously. For a multi-agent system like Prometheus, which has to analyze countless interactions, this isn't just a speed upgrade, it's a fundamental transformation. And right here, in Prometheus's own words, the goal is crystal clear. This exponential boost in processing power isn't just about doing things faster. It's about solving a whole new class of problems that are, right now, with classical computers, simply impossible to tackle. All this computing power is impressive, for sure, but where does it actually create value? How does this technology translate into real-world impact, both globally and right here in Brazil? The potential applications cut across the most complex sectors of our economy. And we're not talking about small improvements. In smart grids, for instance, it means predicting energy demand in real time, neighborhood by neighborhood, and rerouting power to prevent blackouts. In Industry 4.0, it means a factory floor that reconfigures itself based on customer demand. The impact is systemic, and this isn't just some abstract idea. The Prometheus architecture is already being thought about for solving really high-complexity challenges in the Brazilian landscape, as we're about to see in a very specific example from the airline industry. In its self-analysis, Prometheus actually positions itself as a collaboration optimizer for goal líneas aéreas. Now, why is this so relevant? Because running an airline is a giant, real-world, multi-agent system. You've got ground crews, flight crews, logistics, maintenance. Applying this architecture here shows exactly how Prometheus is designed to bring order and efficiency to these massively complex operational ecosystems. Naturally, power on this scale raises some critical questions. And what's really interesting is that Prometheus's own documentation spends a lot of time on these ethical challenges. And these challenges are huge. The explainability question is a perfect example. In a system with a single AI brain, you can at least try to trace a decision. But how do you explain a decision that just emerged from the negotiation between hundreds of autonomous agents? How do you make sure that collective decision is fair and free of bias? These are not easy questions. And the system itself, in its own documentation, acknowledges this responsibility. The stated commitment is that the search for transparency and fairness isn't just an add-on feature. It's a central part of its ongoing development. Ethics are being programmed right into its core. And that brings us to our final question. The technology is almost here. A self-organizing AI system with quantum potential, capable of making strategic decisions in our most vital industries. Prometheus promises a revolution, but the real question is, are we, as a society, ready for it? Thanks for tuning in.